Hello everyone and welcome back to our low-level design course. Today is day 44 and we are going to explore two of the most crucial characteristics of good software design, extensibility and maintainability. In today's fast-moving tech world, it's not enough for a system to just work with its build. It must be built to grow, to adapt and to survive change. Let's dive deep into how we achieve that. Our session today is designed around the three key goals. First, we will understand exactly what extensibility and maintainability mean in the context of software systems. Second, we will discuss why these two attributes are not optional but absolutely critical for the long-term success of any product. And finally, we will learn practical design techniques that help embed these qualities into our code right from the start. We will walk through these examples, spot bad practices, and suggest improvements. By the end, you will have a strong mental model to apply these principles in real-world systems. Let's begin by understanding extensibility. Imagine you have built an e-commerce website. A few months later, marketing wants you to add coupons, loyalty programs, and new payment options. If your system is extensible, adding these new features feels natural. You can extend functionality with minimal changes. However, if your design was rigid, even small changes could cause ripple effects across your code base. In simple terms, extensibility is about future-proofing your system. It means designing in a way that welcomes growth without fear of breaking what's already working. Next, maintainability. Software isn't just written once, it is read, modified, debugged, and enhanced countless times after its initial release. Maintainable code means it's easy for someone, maybe even someone other than the original developer, to understand, fix, and safely improve the code base. Think of maintainability as a gift you give your future self or your future team. It depends heavily on clarity, simplicity, consistency, and discipline. Well-documented, well-structured systems can be maintained with confidence, saving time and reducing errors over the life of the system. Now let's look at what happens when extensibility and maintainability are ignored. You get tightly coupled code where small changes require risky, wide-reaching edits. You see unnecessary complexity that confuses everyone, poor naming that hides the true purpose of components, and lack of modularization that forces complete rewrites instead of small upgrades. Ignoring core design principles does not just make life harder, it can cause projects to fail, systems to crash, and businesses to lose money. Recognizing these pitfalls early allows us to build strong systems from day one. So how do we actively design for extensibility? First, always program to interfaces, not to concrete implementations. This decouples your code and allows you to swap or extend behavior easily. Second, apply the open-closed principle. Your code should be open for extension but closed for modification. Third, modularize. Break your systems into smaller, well-defined components that can evolve independently. And finally, whenever possible, prefer composition over inheritance because composing behaviors dynamically often offers greater flexibility than rigid class hierarchies. Maintainability is all about making your code easy to understand and easy to change without introducing bugs. Start by writing small, single responsibility classes that do one thing well. Use consistent, meaningful names for variables, methods, and classes. Keep functions short and focused. Always strive for strong test coverage. Good unit tests act as living documentation and a safety net for refactoring. And remember, refactoring is not a luxury, it's a continuous investment. Regular cleanups and small improvements make a huge difference over time. Let's look at a classic bad design example. Imagine a payment service class where every new payment method, credit card, PayPal, cryptocurrency is handled with a growing change of if-else statement. Every time we add a new method, we touch existing logic. This violates the open-close principle. It becomes error-prone, hard to test, and harder to extend as requirements grow. One day, one wrong change can cause the entire payment processing to crash in production. Now contrast that with a better design. Here we define a payment gateway interface. Each specific method like credit card payment or PayPal payment implements this interface with its own logic. The payment service now depends on the abstraction, not the concrete classes. To add a new payment type, we simply create a new class implementing the interface. No changes needed in existing tested code. This design is safer, cleaner, and scales beautifully with new business needs. But here's a word of caution: don't fall into the trap of over-engineering. Just because something might be needed in the future does not mean you should build it today. Stick to the YAGNI principle: you aren't gonna need it. Design for realistic future scenarios based on well understood needs, not imaginary possibilities. Balance foresight with pragmatism. A system bloated with unnecessary abstractions can be just as harmful as one that's rigid. Now let's engage a little. Think about a simple shopping cart system, one that lets you add products, calculate total prices, and check out. If tomorrow the business wants to add a discount system or handle sales text differently or introduce flash sales, how hard would it be? What would you need to modify? Could you add features without breaking things? Pause and reflect on how you would improve the design to better handle changes with minimal friction. Today we learned that building software is not just about making it work, it's about making it work well over time. Extensibility allows your system to grow without fear. Maintainability keeps your system understandable and safe to modify. Both are essential for reducing technical debt and ensuring your code base remains a valuable asset, not a reliability. Remember, good design pays for itself again and again in the long run. That brings us to the end of today's session. Thank you for your focus and engagement. In our next session, we are going to shift gears and discuss how to design systems that are concurrency friendly, a critical topic in our world of multi-core processors and distributed applications. Until then, keep happy coding and keep designing for growth.